We spend so much of our lives on roads, right? But have you ever actually stopped to think about what's holding them up? Today, we're going to peel back the asphalt and look at the incredible, hidden science that makes all of our daily travel possible. Let's dive in.
I mean, seriously, think about it. It's not just a thin layer of blacktop spread over some dirt. It's this massive, carefully engineered structure. It's designed to support thousands upon thousands of tons of traffic every single day for decades on end. So what's the secret?
So here's our roadmap for this explainer. We're going to start with the absolute basics, the foundation. Then we'll get into the crucial planning phase, the blueprint. We'll look at the ingredients, see how the land is literally sculpted, tackle some of the tougher challenges, and then finally, we'll wrap it all up with the big picture.
Okay, first things first. Long before any pavement gets laid down, engineers have to build the ground that it's all going to sit on. This is, without a doubt, the most fundamental part of building any road.
The official term for this whole process is road earthworks, or togong in Korean. And it's not just about, pushing dirt around. It is a precise science of cutting, moving, filling, and packing down the earth to create a foundation that is not going to sink or shift or fail. It is the unsung hero of every single road trip you've ever taken. So what does this foundation actually look like? Well, it's all about layers. Right underneath the pavement, the part we drive on, is the roadbed or nosang. Think of this like a mattress. It's got to be perfectly smooth, and it distributes all the pressure. But beneath that, you've got the subgrade, or noshe, and that's like the bed frame. The mattress is for comfort, sure, but the bed frame is what's really carrying all the weight. If you have a weak subgrade, everything on top of it is doomed to fail.
Okay, so we know what the foundation is, but how does it actually get built? Well, you can't just fire up the bulldozers and start digging. Every single move is planned out with incredible detail, because the success of a multi-million-dollar road project depends completely on the quality of its blueprint.
Yeah, this is not guesswork. Engineers follow a very strict set of guidelines. In Korea, for example, that rulebook is the Korean Design Standard, KDS 443000. This document lays out literally everything, from how to survey the land to the exact specs for materials. It's all about ensuring every road is built to the exact same high standard for safety and durability.
The whole planning process really boils down to 3 key steps. First, they do a deep dive on the site itself: geology, soil types, the lay of the land. Second, they lock in the final route, trying to find the path of least resistance. And third, and this one is so important, they create what's called a soil distribution plan. Basically, they figure out ahead of time where every last bit of excavated earth is going to go.
Now, that soil distribution plan is only as good as the materials you have to work with. You just can't build a strong, lasting road out of bad dirt. It's as simple as that.
Engineers are extremely picky here. They want materials that are stable and predictable, like rock and gravel. What they have to avoid at all costs are things like organic soil full of tree roots, or even worse, garbage. That stuff decomposes and compresses over time, which would cause the beautiful new road right above it to sink and crack. So using the right ingredients, it's absolutely non-negotiable.
And to get super precise, they use systems just like this one, the Unified Soil Classification System. It gives every type of soil a code, like G for gravel or a C for clay. This lets an engineer know in an instant what a soil's properties are. Is it excellent for building, like gravel, or is it poor, like silt, which they might have to dig out and replace entirely?
Okay, so the plan is set, the materials are approved, now the real work begins. This is where crews physically start reshaping the landscape to match that blueprint.
The first half of this massive job is called cutting, or chungaki, and it is exactly what it sounds like. Engineers literally cut through hills and high ground, carving out a path where the road is going to go. And the other side of that coin, of course, is filling, or huksaki. This is where they take all that good material and use it to build up low-lying areas, like valleys, bringing them up to the same level as the cuts. It's the perfect counterpart. Now, here's where the real genius of the plan comes in. In a perfect world, every single truckload of rock and soil they dig out of the cut sections gets used to build up the fill sections. This balancing act is called soil volume distribution. And when they get it right, it means no material is wasted and they don't have to truck in extra dirt. It saves a massive amount of time, money, and fuel. It's all about efficiency.
And as they fill, they compact, over and over and over. We're not just talking about running a steamroller over it a few times. No way. That roadbed, the mattress layer we talked about,
has to be compacted to at least 95% of its maximum possible density. If you miss that target, even by a little, water gets in and you've got potholes and cracks within just a few years. But if you hit that 95%, you've built a foundation that can handle decades of traffic, no matter the weather.
Of course, the real world is rarely a perfect balance of soft, easy-to-move soil. Sometimes the landscape fights back, and engineers have to deal with some seriously tough terrain.
A bulldozer isn't going to do much when you run smack into a mountain of solid granite. So, how in the world do they carve a road through that?
The answer is controlled blasting. And let me tell you, this is a highly technical science. It's not just one kind of explosion. They have different methods for different situations. If they're working near homes, they'll use a Type 2 precision blast to keep vibrations to a minimum. But if they're out in a remote open area, they can use a much larger Type 6 blast to get the job done more efficiently. It's always about using the right tool for the job.
Now, after you've cut through all that material, you're left with a slope on the side of the road. And the angle of that slope is absolutely critical for preventing landslides. Hard, solid rock can be cut into a really steep slope, but soft soil, that needs a much gentler angle to stay stable. Getting this calculation wrong can have, well, catastrophic consequences.
So let's bring this all together. From that very first survey to the final press of the compactor, every single step is part of creating this hidden masterpiece of engineering.
The meticulous planning, the careful choice of materials, that perfect balancing act of cutting and filling, the precise science of compaction and blasting, all of it comes together to create this powerful, invisible structure that we rely on every day.
And that really is the main takeaway here. We see the painted lines, we feel the smooth asphalt, but the real strength, the thing that makes it all work, is the foundation. It's the road beneath the road. So the next time you're on the highway, or maybe driving down a road that's been carved into a mountainside, maybe you'll think about the incredible amount of planning and science and just sheer effort that went into creating that solid ground right beneath your wheels. Thanks for joining us.